Hi everyone. Today we will demo our audio sampler app made in the MATLAB App Designer. Our app can load, play, edit, and create sounds. In our team, we split work clearly. I am the Xingyan and I focus on the GUI layout, the playback controls, and the keyboard live mode for quick triggering. Function worked on the DSP editing functions like trim, volume, reverse, speed, and delay. 陆金彤 Huang worked on visualization and synthesis, including the real-time waveform cursor, the FFT magnitude spectrum, and the scene tone generator. Now I will start with a quick live mode of the main interface. First, I clicked pad 1 to load the sample. On the right, you can see the waveform updating while the audio is playing. If I press pause, the playback pauses, and if I press play again, it continues, and stop ends the playback. And we also support the keyboard shortcuts. I can press 1 to 9 to trigger the pads. Space is pause, S is stop, and the L talk loop. This is our rich feature for live triggering. And here is the delay slider. When I move it, you can hear the echo change in the real time. And we can also add a current pad with those buttons like trim, volumes, reverse, and speed. For example, I can click the reverse and now the sample plays backward. And finally, we have the simple sign. I choose the sign, select the target pad, pad 1, and click the save to pad. Now the generated sound is stored in the grid. We can play and edit like the normal sample. So that's the quick demo. Next, we will explain the editing DSP functions and the visualization features in more detail.
Hi everyone, I'm Fang Shang. In this project, I mainly worked on the DSP editor tools. I wrote the backend functions as separate DOM files and the GUI codes then in the callbacks. And our ideas is module design. Each editing feature is one function files like fx train DOM and fx rise DOM, fx speed DOM, fx value DOM, and fx delay DOM. The app only passes in the audience data and the parameter, and then stores the output back to the selected pad. This makes the system easier and maintain the extend. First is chain. With the fx chain DOM, we choose the start time and the end time, and keep only that segment that this helps us get the clean clips and remove unwanted paths. After training, we want the phone becomes shower and the sounds change immediately. Next is revise. FX revise DOM simply flips the audio victory. So the simple plays backward. This is classical audio effect is easier than notice in the DOM. And then we have the speed. In the FX speed DOM, you change the playback play speed by the resampling the single. If the speed is fast, the simple becomes slower. If it is lower, the simple becomes longer. We use the interpolations so the result is smooth and does not sound too broken. For value of x value that's the simple linear scaling. Multiply the signals by the gain value to keep it safe. We also add the leader or normalization so the peak is not the clip and cause the distortion. Our more advantage and advanced effect is delay, which is also the rich feature. The affects the delay model. We can take the delay time from the slide, creating the delay copy and mix with the original single. We also use the feedback idea so the echo can repeat softly. This makes the clear echo sound, and you can hear the difference in the real time when you change this slide. And one challenge is to keep the audience safe and the UI responsible. For example, speed change needs resampling and interpolation, and the delay needs the careful mix to avoid clipping. So we keep each function small, testable, and return clean output back to the app. To sum up, our part is the DSP added layer. Training, revise speed, volume, and delay are implemented and to supply the DOM functions. And this model design make the app easy and maintain the extend. And next, the 洛金同行 want to introduce the virtualization and synthesize.
Hi everyone, I'm Luoxingdong Huang. I'm responsible for the real-time waveform plot and the frequency spectrum plot. During playback, we use a timer to update the play cursor position. So the waveform display is dynamic, not a static screenshot. First, in the upper middle area, I will play a sample. You can see the waveform and the red cursor moving. This part is done by update play axis point I fields. It draws the waveform once, and during playback, it only updates the cursor position, so the app stays smooth. I also downsample long audio for better performance. Next is the sense. When I click sign or square, the sound is generated by sine twin point I'm fields. It takes the tap, sample rate, frequency, duration, and amplitude, and returns the audio data. I also add a short 5 milliseconds fade in and fade out to avoid clicks, and I normalize if the peak is too high. Now I choose a target pad in the drop-down, and I click Save to Pad. This stores the generated sound into the 3x3 grid. After saving, I select the pad and press to play to hear it. The lower right corner is our reach feature, FFT magnitude. The spectrum is computed by with spectrum M fields. It removes DC offset, uses a hung window, and converts the result to dB. I also add a small value to avoid log zero. Then plot spectrum M fields draws a spectrum with labels, limits, and grid, so it is easy to read. One non-trivial challenge was real-time plotting. Redrawing everything is slow, so we plot the waveform. Once the and only move the cursor during playback. This keeps the app responsive. To sum up, our system can load, play, and edit audio. It can also do real-time waveform and spectrum analysis, and it supports editable synthesizer sound. Overall, the design is well structured and engineering focused. Thank you, everyone.